All right, ladies and gentlemen, we're going to continue our activity for the optical rotation of molecule X and its enantiomer. And it guides us through the steps. And this is from a test, so you are guided on the test as well. Remember, these units are mandatory. You don't have options here, people. So if you see something that's not grams, you're going to change it to grams. That's what I'm doing first. No calculator. So I don't want to hear anything like 0.75. It's not wrong, but how many grams is 750 milligrams? Keeping in mind, there's 1,000 milligrams in a gram. And I don't want a decimal, I want a fraction. I got the same look this morning. They zone out as soon as they hear the word fraction. They do. That's what I wanted to hear. He didn't zone out. Thanks. You recovered. 3/4, 3/4 of a gram, right? It's 750 over 1,000, isn't it? Yeah? That's the conversion. Both divide by 25, 200, both divide by 250. 750 divided by 250 is 3. 1,000 divided by 250 is 4. Now what about the decimeters? How many decimeters is that? Remember, that's 80 hundredths. That's centimeters, or hundredths, right? And how many tenths is that? Don't say 800. Oh no. Yeah, that's the right direction. 8 decimeters. And I am going to standardize my alpha observed. There's the standard for alpha observed. Use the equation on the, oh, it's not on the screen. It's now on the screen. Standard of an observed is the actual observed value you saw in the lab divided by C times L. So in the question, what is the observed result in the lab? The resulting rotation under these conditions was what? The resulting rotation was what? Minus 30. Dividing by, I need a thinner pen. Dividing by 3/4 grams over how many milliliters? 3/4 over how many milliliters? Yeah, 24. Okay. You're freaking out already, right? And what's the path length times L? Oh, what just happened? Okay. Times what? 8. People, please try to simplify this thing. Now, some of you, maybe you can simplify it better if you remember 8 is the same as saying 8/1. Can't the 8 and the 4 do something with each other? Yeah. Divide 8 by 4, you have 2. Divide 4 by 4, you got 1. What about the 30 and the 3? Come on. Yeah, 10 on top. Negative 10 if you want to be picky. And 1. Yeah. So what we're left with, negative 10 over 1/1 over 24 times 2/1. Can't we do the 2 and the 24? So now it's just negative 10 times 12 if you think about it, right? Negative 10 over 1/12. The negative 120. Finally get to put that up there. So I know a couple things. I know the stuff's not pure. I know it's not pure. Do you know how I know that? If it was pure, the number would be negative 150. So I have the other enantiomer in there. I know it. Okay. Here's a new equation I didn't put on the notes earlier. You can figure out the percent enantiomeric excess very easily. Optical purity, percent enantiomeric excess is what that stands for. Enantiomeric excess. And it's how much more of one isomer there is than the other. Should I write that down? Percent enantiomeric excess. Defined as how much more there is of the major isomer in percent. Okay. Here's what you do. You take that thing you just calculated, the standard observed rotation, and compare it to the reference standard rotation. And the signs don't matter. So you do that. What's that? What are those things? Straight vertical lines. And that thing just again. Computer does weird stuff. Absolute value correctly defined there. Thank you. It's going to happen again. My computer's not happy today. All right. Times 100. Let's verbalize it. Is that box again? This. Wow. I think that the whole problem was the straightening tool. Control Z. Wow. I created a monster. Need my whiteout. Crazy times call for crazy measures. Oh, yeah. Absolute value times 100. So what was the standardized observed rotation? Negative 120. Reference value, negative 150. Absolute value times 100. I don't think it's as hard as it looks. They both clearly divide by 3. You can use 5. Yeah. I think, well, the 3 will get you the 40 over 50, right? And that'll do it for us. I like that. Let's do the 3. Divide both by 3. Equals 40 over 50 times 100, correct? Is my math good? 120 over 3 is 40. 150 over 3 is 50. Yes. And well, I like this because 40 over 50 is the same as 80 over 100, right? We're done. That's 80%. Let's give it a red arrow. %, EE. Now, there's only one way to read that. There's 80% more of the major isomer than the minor. There's 2 isomers. We'll call it molecule X, and it's an enantiomer. They add up to 100% of the isomers. Okay, there's only 2 molecules in it. They add up to 100%, and they subtract and give 80. I need the percent of each isomer. And then I'll give you an easier way to figure out what you just figured out. It's not coming to you real fast. I'll tell you, if I had a 50-50 mix of enantiomers, you know the answer. If it was a 50-50 mix, the excess is 0, and they're 50% each, and the rotation would be 0. 80-20 is an EE of 60%. You see what I'm saying? 80-20. She proposed an answer of 80-20, and it's not the right answer, is it? Because the excess between 80 and 20 is 60. And we need an excess of 80. So I need your 80 to be higher and your 20 to be lower. And they have to add the 100 still. We're going to hit it by trial and error. We're going to get there. Did somebody say 90 and the 100 minus 90? Which was? 9. I wanted somebody to say 90 and 10. Okay, did somebody say it? I didn't hear it. I'm sorry. Yeah. So yeah, that's the answer. We have 90% major and 10% minor. That makes the EE 90 minus 10, which is 80, match. Okay. Here's the easier way. That was very troublesome for us, right? It's very systematic. Treat it like this. This solution's behaving like it's only like 80% of one isomer and none of the other. That's what the 80. Because 20% of the solution here doesn't rotate light. Because it's a 50-50 mix of R and of one enantiomer, and it's an isomer. So we have a word for that. So that part of the solution, the 20% that doesn't rotate light because it has equal amounts of both enantiomers. What's the word that says a solution or a part of a solution that has equal amounts of two enantiomers? Should we go find the word? Oh, it was on our description page. It was over here. Oh, it's in red. It's very big. Racemic solutions don't rotate light. They have equal amounts of two enantiomers. Here's your breakdown to get your 90 to 10. 80% EE, mean. Only one thing, 80% major plus 20% that doesn't rotate light. There's a name for that. Racemic. I don't know why I had parentheses. You don't need them. What's racemic defined as again? Equal amounts of two enantiomers. Doesn't that mean there's 10% more major from the racemic portion? And the only source of minor is from the racemic portion. So 90% major, 90% major, 10% minor. And they want major in milligrams and percent. We got the percent. Well, isn't 10% easy to do? What was the total milligrams? 750. What's 10% of 750? 75. You went 1%. Yeah, he said 7.5 by mistake. Yeah, and 90% is 750 minus 75, if you want to think about it. 675. Final answer is this and this. So you take the percent EE from the previous part, and then 100 minus that. Little reminder here, some students will, every semester, they ask me after the fact, they say, where did the 20 come from? Can you answer that, student, for me, please? Where did the 20 come from? It's not a random number. Where did I get it from? The rest of the percent. I like the way you said that. So 100 minus the 80 you've already accounted for. Okay? 100% minus 80% is 20% racemic. So use that system every time and you do well in this question. And ladies and gentlemen, if you get bogged down in part A, don't quit. If you just really can't get an answer for A, invent an answer that's less than negative 150. Any answer. I don't care if it's totally illogical. Because then you can get full credit for the next parts. You screwed up on the first part. You lost 1, 2, 3, maybe 4 points. But you can still, if you invent a number less than negative 150, like negative 75, negative 50, because if you had negative 200, it's impossible in this question. The highest rotation this molecule can ever give is 150. That's when it's 100% pure. Okay? You see what I'm saying? Don't give up. The fractions just got you. You say, I give up. Don't. Okay? Invent an answer, put it in this box, use that down here, because this part's not hard. And hey, why don't you invent an answer that works really well with negative 150? Quick. I don't know. Negative 100. Gives good math, right? Okay, I'm giving away too many tips. Yeah. We got 90% major. Whoa, we didn't even answer the question. Is it molecule X that's major? Oh, no. It might not be molecule X. Okay, before you begin the question next time, you can figure out which one's major before you do any math. If the molecule is pictured here with a standard rotation of negative 150, and in the question, this is also negative where the sign matches, that means this is the major molecule. If the question had a positive 30 here, that means the other molecule is major. That's the one that rotates positive. The only way to get a positive rotation there, over there, is to have more of the molecule that rotates in a positive direction. Make sense? So it's just signs match or they don't. That's your two options. If they match, the major is the molecule that's pictured. The one that's right there, molecule X. If these signs do not match, this sign and this sign, if they do not match, then the major would be 90%, and that's the enantiomer, right? But the signs did match, so the 90% is molecule X. So the answer is highlighted that I need in the box. 90%, 675 milligrams. They'll either match or not. That's your two choices. Okay. No math needed. All right, I'm spent. That's it.